Water is undoubtedly the most significant facet of the universe. A lake, though encompassed by definite boundaries, commands attention because of its vast, static, and tranquil expanse, which is virtually motionless. A stream flows with moderate speed in progressive linear mobility. However, the visual impact of a massive waterfall gushing out of its domain, dropping from soaring heights, is tremendous. The sheer force of the fall leaves you mesmerized. One has to stand right underneath the fall to experience the induced, uncontrollable swaying of the body and understand why it beckons you to harness its abundant power and energy. Bhandardara, located in the Indian state of Maharashtra, is at a distance of 150 kilometers northeast of Mumbai. Bhandardara is blessed with astounding natural beauty. In 1910, an Englishman named Arthur Hill constructed the Bhandardara Dam across the Pravara River for the purpose of irrigation. A unique feature of the dam is that, though it is only 507 meters long, it sustains about 400 million cubic meters of water in the reservoir. The Bhandardara Powerhouse 1, comprising of a single 10 megawatt unit, was constructed by the Government of Maharashtra Irrigation Department, or GOMID, in 1984. It was commissioned in 1986 and handed over to Maharashtra State Electricity Board, or MSEB, for operation and maintenance on a lease basis. The powerhouse was completely destroyed in an accidental runaway failure in 1994 and remained out of service for 6 years that followed. In 1992 to 93, private sector participation in power came up in a big way in India, and the government of Maharashtra decided to privatize this power station on a build, own, operate, and transfer basis by inviting national and international open competitive bids. Several bids received from national and international companies were scrutinized, and the bid submitted by Dodson Lindblom Hydropower Private Limited, or DLHPPL, was judged most competitive and accepted on the basis of the tariff quoted by the company. In January 1999, a lease deed agreement between GOMID and DLHPPL and a tripartite power purchase agreement between GOMID, MSEB, and DLHPPL were signed, whereby DLHPPL would repair and commission the powerhouse and sell the electricity generated to MSEB for 30 years. DLHPPL then approached various financial institutions for procuring finance for the project, and ultimately succeeded in securing finance from Overseas Private Investment Corporation, or OPIC, a department of the US Treasury, and from Indian Renewable Energy Development Authority, or IREDA. Having closed the financial aspect of the deal, DLHPPL went ahead with the selection of the Engineering, Procurement, and Construction, or EPC contractor. The EPC contract was awarded to VA Tech International. The entire project was executed and commissioned in July 2001 and dedicated to the loving memory of Mr. Vital K. Rajadaksha, father of Raj and Pratap. Today, the renewed capacity of Powerhouse 1 is 12 megawatts. The plant operates from a maximum level of 744.7 meters to maximum drawdown level of 720.7 meters. During the monsoons, the water level is above the maximum level and 24-hour spillage water is available through the dam. It is important to note that during heavy monsoon, when there is danger of the dam being subjected to enormous pressure due to excess water, The spillway gates are open to allow this excess water to get siphoned into the Bhandardara River. However, during non-monsoon season, which is October through May, the water level decreases considerably, and the plant has to depend upon the irrigation water release, regulated by GOMID. Water from the reservoir is led toward the powerhouse through an underground pipe 3 meters in diameter called penstock. In the event of an emergency shutdown in the powerhouse, there is a rise in the water level of the surge tank due to the backward flow of water from the penstock, and the water hammer effect is relieved. Thus, the surge tank functions as a shock absorber. A flow meter located in the powerhouse measures current flow and cumulative water consumption. The flow of water from the penstock is regulated by the main inlet valve. The main inlet valve is hydraulically operated using an oil pressure unit. Water released by the main inlet valve enters a circular pipe called the spiral casing and then goes further on to the turbine. Wicket gates installed on the inner periphery of the spiral casing have openings, which can be controlled by the governor for effecting water release on the turbine. When these gates are operated, water gushes out of the spiral casing toward the turbine with equal force in all directions to rotate the turbine. The generator rotor is directly coupled with the turbine through a shaft. Thus, when the turbine rotates, the rotor of the generator rotates as well. The rotor rotates, and hence the magnetic field created in the rotor winding also rotates. There is a separate excitation system which gives controlled DC supply to the rotor winding. The stator of the generator also carries winding which is installed around the rotor in such a way that when the rotor rotates, the rotating magnetic field is cut by the winding installed in the stator. Hence, as per Faraday's law, electricity is generated in the stator. The spent water drops down into the draft tube at downstream river level pressure and is then led on to the tail race, both of which are designed to recycle the water for irrigation and drinking purposes. The generator is cooled by air, and the air in turn is cooled by water stored in a small tank, and the spent water is used for gardening. A high-tech, fully automated supervisory control and data acquisition, or SCADA system, is directly connected to all of the equipment in the powerhouse. The control room monitors and controls the functioning of all parts of the plant. All pieces of equipment have been individually tagged with alarm and trip settings to protect them from getting damaged in the event of an abnormal sign. The complete automation of the control system allows the use of minimal manpower. The 11 kilovolts of electricity generated by the generator is carried through cables from the powerhouse to the switchyard. There, the voltage level is stepped up from 11 kilovolts to 132 kilovolts. Thus, power at 132 kilovolts is supplied to MSEB for onward distribution to major cities like Igatpuri and Nasik. Arising from recommendations made by various manufacturers, coupled with first-hand experience of running the power plant, an exacting and meticulous schedule for checking the performance of each piece of equipment has been outlined. The encouraging result of this preventive maintenance measure, executed by the experienced staff of the project, is reflected in the performance profile of the powerhouse. This has resulted in plant availability of up to 99.99%. Mandatory safety measures, such as use of helmets, goggles, and gloves, are strictly complied with, and, should the need arise, a first aid box is always available for use. Safety instructions are signposted at accident-prone areas. Sand buckets and fire extinguishers are located at different places all over the plant. In its 3 years of functioning under the supervision and guidance of DLHBPL, there has never been a single mishap in the operation. Rajgriha, the company guest house, provides family accommodation for the team of engineers. Additionally, self-contained rooms are designed to accommodate visiting staff from DLI and DLZ. Other features of Rajgriha include a conference room, mess, well-equipped kitchen, and outdoor sporting facilities. A sprawling, open-to-sky terrace gives a breathtaking view of the astounding beauty of Bhandardara. Eco-friendly solar panels are used to provide hot water in the guest house. Bhandardara Power Plant 2 has recently been awarded to DLH-PPL. Negotiations are on with MSEB for power purchase agreement and with the Government of Maharashtra Water Resources Department for a lease deed. Financial closure of Bhandardara 2 is expected by June 2005, after which both Power Plant 1 and 2 will run in tandem. DLH-PPL is pursuing the initiation of similar hydropower projects in various parts of India. That brings us to the end of this presentation. Thank you for your time.